Hello, everybody. Mr. Rubo here. Today we are still in 2.2. We are now going to do some word problems. So we got a couple examples here. We're going to go through it, kind of work through it, and then yeah, that'll be it for the video. So we're going to do example 2 and 3. So example 2, we'll go ahead and read this one. A wild rumor spreading that Mr. Rubo won third place in the World's Strongest Man competition. Mr. Rubo definitely probably didn't start the rumor. The number of people that have heard the rumor can be modeled using a geometric sequence. So right there, that's really important. That uh, Mr. Rubo's really strong. Just kidding. That we're using a geometric sequence where the 43 people had heard the rumor on day 3 and 140 had heard it on day 6. According to the model, how many people to the nearest whole number have heard the rumor by day 10? So our first step is figure out the function. Once we know the function, then let's go ahead and write, or then let's figure out what it would be at day 10. So we know it's geometric, so I'm going to put a little table just to kind of organize things. So I know at N3, day 3, it was 43 people, and at day 6, it was 140. So there's kind of my two data points. And what I'm going to do is I'm going to use the one function, and I'm going to use the sequence function. Technically, I could also use the function notation if I wanted to, but I'm going to use this guy. Because the thing we don't know right now is we do not know what our R value is. And that's what we got to figure out first. Once we know our R value, we have equations that we can set up based on any point, so we can get there. So what I'm going to do is I'm going to say my N is 6 and my K is 3 using these 2 points. So we're going to go ahead and do G of 6, which is 140, equals G of 3, which is 43. R we do not know, and then N is 6, K is 3. I did choose that the N was the bigger value just because I knew the subtraction. I'd rather not deal with negative exponents. You can still solve it. It's just easier to not have to. So this is why this problem is Calc OK. My first step after I do 6 minus 3 is to divide by 43. Okay. And you do get a pretty ugly decimal. Okay, so I'll have r to the third equals, and this I'm going to write out, but this is all in my calculator. So, right, so I have 3.2558 ... because it keeps going. And when we're doing the math in the intermediate steps, we don't want to round. I'm rounding on here just for the sake of showing it, but I'm doing all this work in my calculator. Right? Now, to get rid of something to the third power, well, you take the cube root of both sides. And this will give me my R value. So again, I want to use this value constantly. So if you're using a calculator, you're going to keep using this answer. If you're using Desmos, you copy and paste that whole thing because we don't want to lose any accuracy. All right, so now I have my R value, which means I can go ahead and now write a function. So G of n equals, and I'm going to say G of 3 because I'll make my K value still 3, of 1.48213. Oh no, my pen stopped writing. There we go. And again, this is all in the calculator, so where I'm copying and pasting from Desmos. And then n minus 3. And again, say G of n equals 43, 1.8213, ... n minus 3. There's my function. I'm done with that part. But now I actually have to answer the question, which is at day 10, which means I'm finding G of 10. And again, I'm going right to my calculator for this, but I'm writing out the steps for the sake of this video. So I got 10 minus 3, which would be 7 up here. And I'm typing this all in, and you would get about 676 people. It does say to the nearest whole number, so that is why I rounded there. And yeah, to 676. And again, if you round your R value too early, you will get a very different number. So make sure you keep that answer for your R the entire way. Right? You only round at the end. Don't round in the intermediate steps. All right, so there is a geometric sequence problem. Here is an arithmetic one. So example 3, a large theater has rows of seats where the number of seats in each row can be modeled by an arithmetic sequence. If the fifth row has 31 seats and the 11th row has 49 seats, determine how many seats there are in the 25th row. So same idea as before. I'm going to do just a little table just so I can organize. So 5 gave me 31 and 11 gave me 49. Technically, there's a few different ways I can go about this. I'm going to go the kind of similar approach I did up above for the geometric, just using the, oh no, my pen, doing it again. I'm just going to use the arithmetic sequence formula. So, and I have to figure out what D is instead of R this time. And here again, I'm going to make the bigger number N, smaller number K. Again, that's because I know I'm doing N minus K, so I just rather not deal with negatives if I can help it. So I'm going to say 49 because that's A sub 11. A sub K would be 31 plus D I do not know, and then 11 minus 5. Start simplifying, subtract the 31, get 6 times D, so D is 3. And yeah, that one definitely doable without a calculator. And then once we know what D is, now we go ahead and write our equation. So A sub n equals, and we're again still using K as 5, so 31 plus 3 times n minus 5. And there we go. There's our equation. So now let's go ahead and substitute in 25. So I'm going to say A sub 25 equals 31 plus 3 times 25 minus 5. And you simplify this, you get 3 times 20, which is 60, plus 31. So A of 25 is 91 seats. And there we go. So there's kind of two examples of some word problems with geometric and arithmetic sequences. So thanks for watching. Have a good day.